Excuse me. So we're going to talk about key features of exponential functions in this video. I've got some graphs, some tables, and some equations, and we're going to figure out what exponential functions look like on a graph, which we kind of already started doing with our geometric sequences, but we're going to dive a little deeper into them today and look at what their key features are. So domain, range, if there's intercepts, what our increasing intervals look like, what our decreasing intervals look like, and we're also going to start talking about end behavior. So the first one I have is a graph. You will notice I did add some arrows on the end of this because we know that since this is an exponential function, those two sides are going to be going on forever. So I'm always going to be going in this direction. I'm always going to be going in that direction. So since we're traveling on forever, my domain is always going to work. Every single x value we could ever possibly imagine will work for this graph. So there's a couple ways I could write that. We could use our interval notation, or excuse me, our inequality notation, because those are inequality signs. Or we could write all real numbers. So for our range goes with y. So it's all of these numbers up here. Now, I haven't given you this vocabulary yet, but it looks like this graph is going to touch 0. But in actuality, it's never really, truly going to get to y equals 0. It's going to get really, really, really close and be like 0.000000000000001. A super duper small number, but it will never actually be equal to 0. So how I write that with the range is that my y values are going to be greater than 0, but in this case, I'm never going to actually get to 0, so I do not put an equal sign. My y-intercept I can see right here is 0, 1. I'm going to skip end behavior for just a minute, and I'm going to talk about increasing and decreasing. As I move from left to right, if I was a little ant crawling along this graph, I would always be increasing. So there is no decreasing interval because it's never going down. It is always going up. So for our increasing interval, it's actually going to be the same as our domain in this case. So for our end behavior, we're gonna kind of write this in two different ways. Here, I know that my y value is going towards 0. And here, I know that my y value is going towards positive infinity. Ooh, there we go. So what I need to write, now that I have those two pieces, is what's happening with x. So for these numbers over here, my x value is going towards negative infinity because it's all of these numbers, all the way down to negative infinity. Y is going to go to 0. And as my x values are going to positive infinity, so everybody up this way, y is stretching way up to the sky, going up to infinity. Oop, I didn't leave myself very much room there, did I? Now, end behavior, is one of those things that's kind of like an extra thing that I've added in. That's like our bonus for this. But as long as you feel good with domain, range, y-intercept, and increasing, and you're okay with these pieces, I'm not super worried about end behavior if you're not perfect at it right now. So what I want to talk about is this. Why y isn't actually getting to 0. So it's called an asymptote. If you've ever heard that song by MC Hammer called Can't Touch This, that's how I like to think of an asymptote. With exponential functions, we are going to have horizontal asymptotes. And it's this imaginary horizontal line that our graph or our equation or our curve is going to get really, really, really close to, but it's never going to actually touch it. So in our last example, our asymptote was this line right here, y equals 0. And I used that to help find our range. So here's our next example. Now I'm giving you a table. So one thing that when we look at a table, we can find right away, in this case, is our y-intercept, because that happens when x equals 0. So our y-intercept here is 0, -4. And if you think about what's happening with these numbers based on our table, I can also find our increasing and our decreasing intervals. So these numbers for x are going up. Let's look at our y values. -16 to -8 to -4 to -2 to -1. Those numbers are also going up. So this is another scenario where I don't have a decreasing interval, and it's always increasing. And again, my domain is going to be all real numbers because all the numbers for x work. Now, I do have this graphed so that we can look at this. I'm going to make this go away. So here are my points. So you'll notice this curve is going to start to stretch. And I'm going to get really close to, but not actually ever touch, again, y equals 0. So I have the same asymptote, but a very different looking graph. It is always increasing. However, all of my y values are now 0. So I'm going to switch back over to here. So everybody's negative. That means all of my y values are going to be less than 0. So just in case you want to keep that in mind, my asymptote is y equals 0. So I get super close, but never actually touch 0. So this graph, if you remember from what we just looked at, it looks like this. So I have to figure out what happens with my negative x values. And I have to figure out what happens with my positive x values. So here, my negative x values, well, now y is going to go to not -8, oy vey, -infinity, because it's going down. So left-hand side, my graph is going down. And then my right-hand side, y is going to 0. All right. Now I'm going to give you an equation. So if you think back to what we did for our geometric sequences, this is my common ratio. Here, I don't have an x minus 1 or x plus 2 or anything like that. So I know that my first term is the x value of 0. So this is my initial value, or my starting term. And since there's nothing here, I know my first input, like we were doing with our table, would be x equals 0. Y'all, if x equals 0, that's my y-intercept. So my y-intercept here is going to be 0, 2. I've got a domain of all real numbers again, because every x value we could ever think of is going to work. Now I have to think about what's happening with this ratio. And I do have a graph that we'll look at here in just a minute. If it's 1/3, that means as I'm moving down my table, I'm always dividing by 3. So my numbers in my table are going to get smaller and smaller and smaller. That means I'm not going to have an increasing interval this time, and it's always going to be decreasing because of this number right here. This is the one we were looking at. All right, so I'm going to switch over to my graph. I'm going to turn this one off, and I'm going to turn this one on. All right, so here is my graph. You can see, just like we talked about with that 1/3, it's always decreasing. I still have an asymptote of 0. Even though it looks like it's going to get to 0, we know it's not because of that horizontal asymptote. If I look right here on my graph, my y-intercept is 0, 2, and then my numbers are going to keep going down from there. So I'm going to switch back to my paper. So my range, y is still all of my numbers that are greater than 0. Just as a reminder, my asymptote is y equals 0. So now in this case, my graph was going like this. So on the left, y is going up to the top, and on the right, y is going to 0. So for my left, it's always x with negative infinity. And this one, y is going up forever. And on the right, it's always x going to infinity. And that's where y is going to my asymptote of 0. All right, so just putting into words some ways that we would find key features. And this could be from an equation or a table or a graph, honestly. We're just going to kind of talk about these all together. Domain is always all real numbers, because all x values work. Our range will depend on a couple things. We need to know our asymptote, And I need to know if it's above or below the asymptote. I'm going to abbreviate that. If it's above the asymptote, that's when my y value is greater than that number. If it's below the asymptote, that's when y is less than that number. To find my y-intercept, I need to find the y value when x is 0. So whether that be using in a table, a graph, or an equation, I'm always looking for what happens when x equals 0. End behavior is going to kind of go with range and increasing or decreasing. I need to look at the left of the y-axis and the right of the y-axis, which is when x is equal to 0. And then for increasing or decreasing, it will always be one or the other, not both. So I've got one more example for us. And we're going to do this one without looking at our graph. So 2/3, if I was in my table, my numbers would be getting smaller and smaller and smaller if it was just 2/3. However, since my numbers are negative in front, now those numbers that were getting smaller and smaller and smaller are all going to be flipped, which means instead of my numbers getting smaller and smaller and smaller because of this, they're actually going to all be negative, which means since they're all negative, they're all actually getting bigger. And let me show you what that would look like on our graph. Oh, I didn't put this in there yet. Oopsies. So I'm going to make this a negative. Actually, I'm going to change this to 2/3 first. Okay, so this is what it would look like if it was 2/3. I see my numbers are going to decrease as I go from left to right. But watch what happens as soon as I put this negative out in front. Did you see it? It was up here when it was positive, and then, bloop, it flips. So now, instead of decreasing and my numbers getting smaller, my numbers are actually getting bigger because it's reflected it. So my graph would look like this. So my domain, again, is all real numbers. My range is y is less than 0 because it's all my numbers that are smaller. There is no decreasing interval anymore. It's all increasing. Now let's think about my y-intercept. If this was 0, anything to the power of 0 is 1. So this would be replaced with 1, and then I have a negative in front of it. So my y-intercept would be 0, -1. Now, if this said a -2 as the coefficient, this would be a 1. I would have a -2 here for my coefficient, so then it would be -2. So your y-intercept is going to be whatever your coefficient is, as long as there's nothing added on the outside, okay? So here's my end behavior. Here I'm going down forever to -infinity, and here we're going to 0. So x to -infinity, remember that's left. So it's going to -infinity for y. And x going to +infinity is the right. So y is going to 0.